Morning students, I am P. Gomati, Assistant Professor, Department of Mathematics. So in this lecture we are going to see about vector calculus and some basic definitions in vector calculus. So the first one is scalar quantity. A scalar quantity is nothing but it has magnitude and is not related to any direction. Whereas vector quantity is nothing but it has both magnitude and direction. So now let us see what is a scalar point function. If the corresponding points P of a region R, there corresponds a scalar denoted by phi of P or simply phi of x, y, z, then phi is said to be a scalar point function for that region R. Suppose if you consider an example, that is the temperature phi of P at any point P of a body occupying a certain region, then that is called as the scalar point function of that particular object. Next definition, vector point function. If the corresponding to each point P of a region R, there corresponds a vector denoted by f of P, then f is said to be a vector point function for that region. So for example, if you consider the acceleration f of P of a particle at any time, it occupies the position P in a certain region, which is called as the vector point function. So for this we are defining an operator, vector differential operator, which is denoted by del, and the formula for this is given by del is equal to I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. So in short we can write this as summation of I vector into dou by dou x. So when you expand this you get the differential operator. Now the next definition is gradient of a scalar point function. Suppose if you have phi of x, y, z be a scalar point function, then it is continuously differentiable over the vector, and that del phi is given by I into dou by dou x plus j into dou by dou y plus k into dou by dou z of phi. So when you operate this phi over all these things, you get I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z, and this is called as the gradient of phi and is written as grade phi. So del phi defines a vector field and del phi is not equal to phi into del. So there will be no dot or x between phi and del. So now let us see some properties of the gradient. So the first one is if f and g are two scalar point functions, then del of f plus or minus g equal to del f plus or minus del g. So we can separate these two. And the next one is if f and g are two scalar point functions, then del of fg equal to f into del g plus g into del f. And the third one is here you are using quotient rule. So if f and g are two scalar point function, then del of f by g equal to g del f minus f del g divided by g square. And always gradient of a constant is 0. So based on this, let us see some problems. So the problem number 1 is you have to find grade phi, where phi is given as x square plus y square plus z square. So del phi is nothing but I into dou phi by dou x plus j into dou phi by dou y plus k into dou phi by dou z. So you substitute the value of phi in all those things. So I into dou by dou x of x square plus y square plus z square plus j into dou by dou y of x square plus y square plus z square and plus k into dou by dou z of x square plus y square plus z square. So which is equal to I vector into, when you differentiate this with respect to x you get 2x, and with respect to y you get 2y, and with respect to z you get 2z. So the answer is del phi equal to 2x into I vector plus 2y into j vector plus 2z into k vector. And the second problem, find grade phi if phi equal to x, y, z at 1, 1, 1. So write down the formula I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. So substitute for phi equal to x, y, z. So I vector into dou by dou x of x, y, z plus j vector into dou by dou y of x, y, z and plus k vector into dou by dou z of x, y, z. So when you differentiate this with respect to x, y and z, you get I vector into yz plus j vector into xz plus k vector into xy. So here the point is given as 1, 1, 1. So you have to substitute for x equal to 1 and y equal to 1 and z equal to 1. Then the del phi value will be I vector plus j vector plus k vector. Similarly, we can do the third problem. So the third problem is find grade phi where phi equal to 3x square y minus y cube z square at 1, 1, 1. So write down the formula for del phi, which is equal to I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z, and replace phi by 3x square y minus y cube z square. So when you differentiate this with respect to x, y and z, you will be getting 6xy into I vector plus 3x square minus 3y square z square into j vector and minus 2y cube z into k vector. So at 1 comma 1 comma that 1, that is x equal to 1, y equal to 1 and z equal to 1. So del phi equal to 6 I vector plus 0 j vector minus 2 k vector. So the last problem, if phi equal to log of x square plus y square plus z square, find del phi. So del phi is equal to I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. So for phi we are substituting log of x square plus y square plus z square. So when you differentiate this phi with respect to x, y, z, so log of x square plus y square plus z square is nothing but 1 by x square plus y square plus z square into differentiation of x square is 2x. Similarly, when you differentiate this with respect to y, you get 2y by x square plus y square plus z square. And on differentiating with respect to z, you are getting 2z by x square plus y square plus z square. So after simplification, we are getting the answer to be 2 into xi plus yj plus zk divided by x square plus y square plus z square. So this is our final answer. Okay, thank you.